To solve an equation containing a radical, there are 4 steps that you need to follow. Step 1 is to isolate the radical. Make sure that one radical term is alone on one side of the equation. Step 2 is to apply the power rule. This means to raise each side of the equation to a power that is the same as the index of the radical. Step 3, you solve the resulting equation. If the equation still contains a radical, then repeat steps 1 and 2. Step 4 is to check all proposed solutions in the original equation. This is important because in some cases one or more of your proposed solutions will be extraneous. That is, they won't check in the original equation and will need to be rejected. Let's look at some examples. In example 1, we have the square root of 3x plus 4 equals 8. Notice that the radical is already isolated, so step 1 has already been done. To do step 2, note that we are given the square root. This means the index is 2. So we raise each side of the equation to the power 2. Raising the radical to the second power will eliminate the radical bar, so we simply bring down the 3x plus 4 on the left side. On the right side, squaring the 8 will give us 64. Next we do step 3, which is to solve the equation. By subtracting 4 and dividing by 3 on both sides of the equation, this gives us x equals 20. Step 4 is to check your proposed solution. This step is very important because we need to know if the solution we obtain really checks. To do so, replace the x in your original equation with your solution and simplify. Notice we end up with 8 is equal to 8, which is true. This means our solution checks. Therefore, the solution to this equation is 20. In example 2, we have the square root of 5x minus 1 plus 3 equals 0. Notice that the radical is not isolated, so we need to do step 1. To isolate the radical, we subtract 3 from both sides of the equation. Now the radical is by itself on the left side, so we are ready to go on to the next step. Step 2 is to raise each side of the equation to the power 2. Again, raising the radical to the second power will eliminate the radical bar, so we simply bring down the 5x minus 1. On the other side, squaring negative 3 will give us 9. Next we do step 3, which is to solve the equation by adding 1 and dividing by 5 on both sides of the equation. This will give us x equals 2. Step 4 is to check your proposed solution. Substitute your solution into the original equation by replacing the x with 2 and simplifying. Notice we end up with 3 plus 3 is equal to 0, which is false. This means our solution does not check. Since this was the only solution we obtained and it did not work for our equation, therefore we can say that there is no solution to this equation. We indicate no solution using a 0 and a slash going through it. In example 3, we have the square root of 4 minus x equals x plus 2. Again, the radical is already isolated, so step 1 has already been done. Step 2 is to raise both sides of the equation to the second power. On the left side, we simply bring down the 4 minus x. On the right side, recall that x plus 2 raised to the second power really means you multiply the binomial x plus 2 times another binomial x plus 2. We can use the distributive property to multiply the two binomials. Doing this will give you x squared plus 4x plus 4 on the right side of the equation. Next we do step 3, which is to solve the equation. Since the equation is quadratic because the largest exponent is 2, we need to put this equation in standard form in order to solve. Recall, an equation in standard form will have 0 on one side of the equation. To do so, we need to subtract 4 and add x to both sides of the equation. We now have an equation that we can factor by taking out the greatest common factor, x. Next, we apply the zero factor property by setting each factor equal to 0. So we have x equals to 0 and x plus 5 equals to 0. Solving for x in the second factor gives us x equals negative 5. Step 4 is to check our proposed solutions. First, replace the x's in the original equation with 0. Upon simplifying, we obtain a true statement, so the solution 0 checks. Next, we replace the x's in the original equation with negative 5 and simplify. This time we got a false statement. This means that negative 5 does not check, so we reject it. Therefore, we only have one solution, which is 0. You should look over the examples on the web page and then test your knowledge using Test Yourself.